Hello, we're starting. We are now applying the pyramid principle to Ethereum development by Josef Gattermayer of Aki Blockchain Security. Thank you.
Thank you. Everyone, so you must really dislike Vitalik, or just for record, he's now on the main stage, so it's kind of challenging having a talk in parallel. But thank you anyway for coming. So my name is Josef. I'm CEO of Blockchain. We are a security company. We are performing security audits, and I'm also assistant professor at the Czech Technical University in Prague. Basically, just what we do besides the security auditing, we are also trying to give something back to the ecosystem. So we are big believers of open source, and we are developing some open source tools. And we are also trying to get back something to the community by providing good education. So we teach one subject at the university, and we are also doing online lessons for free for anyone. We have one school of Solana, and then we have school of Solidity. So basically, we are operating on these two chains, on Solana and on EVM. Oops. No problem. So we are quite lucky that we could be working for some of the top tier players in the ecosystem, namely, for example, our last audit for Safe, or we are auditing every release of Axelar, and we also audited quite intensively Layer 0. And our last audit was made for pro bono, and because we sometimes even help projects that are building some interesting things. And maybe you know Solidity project. That's basically a guy who is rewriting Open Zeppelin Solidity libraries to assembly to save some gas. So we offered him a free audit. And this talk has a little bit abstract name. It's called Security Pyramid. And my motivation for the talk was that when a project approaches us, basically for the audit, in the first day we see with like 50 to 50 probability if there will be any criticals or not. How we do it is basically you can see which security or best practices is the development team following. So for some of you, it may be like very obvious because it's the same in Web 2, Web 3. But I just thought that it's worth mentioning that. And if we save one project from making obvious mistakes, then it was worth to mention this. So basically, the talk will focus on anything you can do before the security audit. And it looks like this. So at the very bottom, the things have the biggest impact and basically are the most fundamental in the development process. And you can see that the audit is like sitting at the top of the pyramid, so it's the top of the iceberg. And of course, it has it's like the final output of the security process, but the impact is that limited. So basically, by having the audit, it doesn't mean that it catches all the previous layers, and the biggest impact you can make on the lower layers, not on the top of the iceberg. So let's get to the single layers. Probably you know that if you're devs, but still it's a surprise that many projects don't do that. So every code should be peer reviewed. It's good to follow the standard Git flow, where basically developers create branches, the future branches, and the future branches then are merged with pull requests, which means like at least second pair of eyes checks the code. And this also is kind of like use case. For example, a lot of projects we have are written by, how I call it, like full stack hero. So basically like one guy who develops the backend, who develops the contracts, and is doing his own peer requests, which maybe sounds good for the investors that we have a one strong dev that can do everything, but it doesn't work. Here's an example. It was a Solana project, but basically which things it can lead to when there's like one guy doing everything. Basically, this is a discussion we had with the developer on Slack, and the developer basically was not handling some edge cases in the on-chain program. And his argument was like, I don't need to handle that because my backend will never send it. But come on, guy, we are in blockchain, so everyone can call your contract, everyone can do everything with that, and this is how it works, and this is how it should work. So, so the tests and everything should take place in the contract. If not, of course, the auditors, what they do in the audit report, this led to 3 criticals, which means basically he has to pay the audit again because with this kind of thing he cannot publish that because, of course, the community wouldn't accept it as a secure project. So that's some of the outcomes of having too much centralization in one person and developing everything. So the next step, unit tests. Probably you have heard about that, but still very few projects have them written properly. So basically, the development team should be writing the tests. It's good to test coverage every function. For the audit, we always say that the test coverage should be at least 90%. Better is 100. Before that, of course, the auditors are very expensive developers of tests, so it's better to do this internally. And also a good practice is if the tests are written in some kind of like different tech, then is the tested one or with different person. So for example, when you have a solid contract, it's good to write the tests in JavaScript or Python, so there's not possible to copy paste just logical mistakes from one language to another. And also, it's important not to test only the happy path scenario, but to test also some edge cases that should not happen. And of course, the test should be part of the CI/CD pipeline, and that's why the selection, for example, of the testing framework also matters, because if the tests take like 2 minutes, so probably then someone will just skip them in the pipeline. So it's necessary that the test execution is very fast. I'll later on speak about some tools that I recommend. So this was kind of obvious, and it's the same for Web 2, Web 3. Where we have some kind of specifics is static analysis, which in Web 3 is kind of helpful. So these are basically tools that you can run over your contracts, and it might find some issues. The problem is that it has many false positives, and there are like different tools with different approaches, but there's none of the tools that basically catches everything and then can replace, I don't know, audit or whatsoever. Even it's like a very sexy story, we have, for the VCs, we have replaced the auditors by a tool that's running on AI whatsoever, give me money, so a lot of projects do that, but in the end, nothing works like this. So there's a tool that quite works well, but what we are always looking for is that the tools have a high precision, which means they are confident about the issues they report, and a lower recall, which means less noise of the false positive issues. And if we move to the 4th stage, so that's something that just a few projects have, and this shows some of like more advanced approach towards security. And when we, for example, open a repo and see that the project has some fast tests, so we can say like at the first auditing day, okay, they probably will pass the audit, because just by having this, it means that they are at some level of the security. So fast tests, again, are written by the development team, and they are trying random inputs on different functions, different contracts, calling them in different order. And with this, basically, you can be quite sure, for example, in DeFi, on mathematics, that it covers some kind of undiscovered bad use cases or bad scenarios. And it's also good to test the external libraries, which is kind of like specifics. And what we also do is we are doing a lot of cross-chain fast testing. If you will be more interested in this topic, there was today a talk by my colleagues called State of Python Testing Frameworks. But just in general, fast testing cross-chain is good, for example, when you are minting an NFT, so you can be sure that it's not minted on 2 chains. So basically on chain A, it's doing some inputs, and it checks the outputs on chain B. And there's also quite interesting technique called differential fast testing, We use it, for example, when there's some kind of like external library that's not too battlefield tested as, I don't know, OpenZeppelin, but it's kind of like not audited, but the scope of the library, of course, exceeds the scope of the audit, so we don't have time or budget to audit the external library, but the library is very important for the project. So how you can do it, if it's some kind of like math library, so you can take math library, implement it in different language that's doing the same, that's more established, and just try the same random inputs on library A and library B and check the outputs. And if the outputs are the same, it's fine. If there's some difference, then probably the library B is not behaving as it should. And we have done it in one of the last audits. So for example, there was a DeFi project using the ABDK library, which is a library for floating point computations. And we have just taken its equivalent written in Python that's called BigFloat. And this BigFloat library is using the C library that's used basically everywhere. So we just assume that this library works. And we have compared it with the Solidity ABDK library. And we have found that on some specific input, it provides different outputs. And we have identified that there's like a precision problem if you compare these two hashes. So it's like on the 6th position from the end. So it's kind of like a problem that's not occurring very often, but still different output, it could mean a problem. And the test was quite simple to test this library with the differential fast testing. And then is the audit. So the audit should be at the very end. And for the audit to be successful, it's good to provide the auditors as much information as possible, because of course you don't want the auditors to be spending their time ineffectively. So what we always prefer is that we need developer documentation, we need diagrams as much as possible, architecture description. Very useful thing is some kind of like video walk through the code base. And the outcome is that, of course, when the stages 1 to 4 are missing, the audit will not save you. So the most probable scenario is in the audit, when we found 1 or 2 criticals, we just write an exploit for that. Writing the exploit takes some time. So for example, when we have an audit for 5 man days, we discover critical, then we are writing 2 man days the exploit for that to verify the critical. And then basically we spend our time on the audit by writing the exploit. So in the executive summary, we just write, okay, we have discovered this critical, then we run out of time, which means fix the critical and order the full audit again, which of course is not the thing that you want to do as a protocol here in the audit. So basically the audit will just tell like, hey, go and return again. So the project still have to do the 4 stages by their own. And as I touched a little bit the audit topic, so there are audits and audits. And at least in our view, the audit is not a stamp. Some protocols prefer that, buying audit from a high-profile auditing brand that just serves good for the retail users as they know the brand. I'm not naming anyone, but you probably know. But the outcome of the audit should be more like this, which means some kind of like very complicated process, which security is. And as a process, it's not like single delivery, which means it's not like one audit. It's always good to audit continuously, which means auditing every release. And the audit serves not just for the protocol, but also for the users. So it, of course, should be public. It should be very easily readable. And by this non-stamp approach, of course, the audit doesn't tell if the protocol is safe. It just tells that, okay, we have tried this, and that, and based on our findings, we see this, but the disclaimer is always like, we cannot take responsibility. But for example, important part of the audit is something that's called trust model, which describes even how, for example, the treasury of the protocol is handled, if there's any multi-signature or whatsoever. And if we see that it's too centralized and, for example, allows some kind of like founders rug pull, we always write it in the audit, because the audit is meant for the public, not that the protocol is paying us, to give them the stamp. So recently there was like, 3 rug pulls in a row of audited projects. So with a good auditing company, this shouldn't happen, because it should be stated in the audit report that this is possible. And of course, the audit should hack the protocol. It should not like find some low-hanging fruit with automatic analysis. It should be about the manual code review. And yeah, so this is how it looks when the critical issue is discovered. Thank you, Midjourney. And with the auditing companies, different companies have different values. So it's of course good to look for some auditors that audit high-profile projects. And like my personal favorite metrics, like the number that I look for is how many times has the auditing company been hacked? What does it mean? If the company audits a protocol and after the audit it gets hacked, it's a problem for the auditing company. On the other side, this can happen, will happen, and happens even to the best players. So what can save the company is the number of projects the company has hacked, which means like the many criticals they found. So if for example, in our case, we in the last 2 years discovered about 62 criticals, and we have been 0 times hacked, which is of course great, but even if the number would be 1, it's still kind of okay. On the other side, when you discover 0 criticals and you are getting hacked all the time, it means that the company probably is worth nothing. And the output of the audit is some kind of holy book, of course, that then the protocol can publish on the website. And I just touched some kind of like best practices here, so I will also include some specific tools that I can recommend. A lot of the tools are written by us, so product placement, but it's open source, so it's a joke, we are not selling it. So for the unit tests, of course, there are like 2 approaches at least, so we can write them over solid contracts even in JavaScript or in Python. We are more for the Python world. For the JavaScript testing framework, Hardhat works pretty well. We have developed Python testing framework, which is called Vogue. Just disclaimer for the name, we found the name first before any movement, so my answer is always why Vogue. We got the Python package name first, so we just don't care. And there's also testing framework in Python called Brownie, but it's now an abandoned project. And there's a testing framework called Ape. And these testing frameworks run against local dev chains, so each of them supports Anvil, Ganache, and Hardhat. As I said, important thing with the testing framework is the speed of execution. So we just wanted to focus on this a bit. So we have taken the 271 unit tests of Uniswap V3 project, which are written in Hardhat. And basically, we have rewritten these tests for Brownie, Ape, and Vogue. So it's quite a lot of work. And then we compared the speed of execution of this test suite over the 3 development chains. And of course, the output that we were hoping for is that Vogue is quite fast here. So we can see that this test suite was executed in 3.5 seconds on the Anvil chain, which is, for example, like 10 times faster than Brownie. And in our view, this is very important because, for example, when we as auditors help the project to increase the test site, then we can just put the test as part of their pipeline, which, for example, was the case of the Solidity project. So basically, they accepted the test suite as a part of their pipeline. And of course, if it will be running 1 minute, they will not accept that. So if it runs 3 seconds, it's kind of okay. And if you'll be more interested, we wrote an academic paper about the evaluation of the testing frameworks. It's now under review, but if you just send me a message on Telegram, I can send it to you, but we cannot publish that. And for the static analysis, the most established static analyzer is Slitter, written by 12 bits, which has a quite has a very good precision, so it's not reporting too much false positives. And then we have a static analyzer in our Vogue testing framework, which works together with VS Code extension that we call Tools for Solidity. So basically, if you are using VS Code, the easiest way how to install Vogue is by just installing this extension, and it loads all the dependencies. And the output is that here is a screenshot of the VS Code, if you can see that. And basically, when a user or the developer, for example, creates an here possible reentrancy, so it opens a dialog where itself testing framework notifies the user that there is a possible reentrancy, so you don't have to run any CI, and you can see just like in your dev environment. And for the fast testing, there's the first and still very good tool from Trailbits called Echidna. And we also have a fast testing in Vogue, where basically we, on top of the specific things for fast testing, we can also support cross-chain tests. And we use it with a lot of projects, for example, that we are auditing on Accelor. And yeah, as the audit is finished, everyone is happy, and this is how it should look like. So thank you very much for your attention. And if there is any question, we still have about 3 minutes. I guess not, so thank you very much.